And 3, it says the IUPAC name of CH2 attached to Cl, this is a substituent. Then we have carbon, this is second carbon attached to CH3, that's another substituent. Then a double bond, right, and CH2. This double bond actually tells us that this compound is a member of the alkene, right? So first off, let's draw the structure. We have carbon, terminal carbon attached to 2 hydrogen, also attached to chlorine, and this is attached to another carbon, right? We have CH3, a double bond, and C, right? 2 hydrogens. Now first off, remember we said that this is an alkene, right? Let me just write here, this I refer to as an alkene. The first question dealt with an alkene, the second was an alkanol. Now for the alkene, this is the functional group, right? The double bond functional group, and we look for the numbering system that will give this double bond the lowest number. We're not considering the substituent, but we're looking for what will give this double bond the lowest number. Let's consider the 4 numbering system. We're going to have 1, 2, 3, right? So we'll pick the one that is closest to the double bond, that's the carbon that is closest to it, right, which is the second carbon. So going through the forward numbering system, we're going to have the double bond on carbon 2, but let's try the backward numbering system. We have 1, right, we have 2, and we have 3, right? So the one closest to it, that's where we're coming from, the double bond become attached to carbon 1, methyl group attached to carbon 2, and chloro group attached to carbon 3. Now if we go forward, we're going to have a total lower number because of the substituent, but we're going to have to go backward. The reason is that this functional group is going to give priority, right? Name organic compounds, we give functional group priority compared to substituents. All right, so let's name the substituent. So we're going to have methyl attached to carbon 2, chloro attached to carbon 3, right? C comes before M, so we're going to write 3 chloro, right? Then we have 2 methyl. Now the longest carbon chain was actually 3, that's the longest continuous was system of 3, and that's prop, right? So the prefix is prop, so we're going to have prop. Then since this alkene functional group is attached to carbon 1, we're going to spell prop 1 in, that's ANE. ANE specifies the functional group, that the functional group attached to carbon 1, and this specifies the position of the substituents, right? It gives the IUPAC name of CH3. We have 3 as a subscript of CH3. I'll explain that. Then we have carbon and the OH. Remember the OH tells us that this OH is functional group. It tells us that this is an alkanol. Right, so let's go solution. As we did before, we're going to draw out the full structure so it's easier for us to name, and that becomes, we have carbon, right, CH3, we have 3 of it. Carbon is attached to here, let's just write CH3, right? Then we have another one here, we have another here, then we have the OH group, right? So this is the representation of it here. Now as usual, we're going to identify the longest carbon chain. Now this becomes a bit complex here because it is not horizontal, right? If we count horizontally, we're going to have 1, 2 as the longest continuous carbon chain, but rather here's what we're going to do. We're going to step downwards, all right? This is the longest continuous. There's no breaking of the line, it's still continuous, so it still counts, right? So, and if you count this is 3 carbon, not 2. So longest continuous carbon chain is a system of 3 carbon. Now this tells us that this is the prefix for this is actually butan, right? Butan. So now we need to find the number this OH we take and also the substituent CH3 we take. Now I'm going to go with the 4 numbering system. Let's try that. We're having 1, we're having 2, we're having 3. right? Now 1, 2, 3. Remember, we're taking the OH as priority, not this methyl group. If we come forward, it falls on carbon 2. If we come backward, which is here, 1, 2, 3, as it was for question 1, it still falls on carbon 2. So obviously this OH group must take 2 because it always falls on carbon 2. So we have butan 2O. And going for that same numbering system, CH3 also falls on carbon 2, so that becomes 2 methyl, right, butan 2O, 2 methyl butan 2O. So that's the correct answer. 5. The IUPAC name of C3H7COOH is dash. Alright, now as we did before, let's write out the full structure representation of this, right? We're going to do that. So let's go solution. So we have 3 carbon attached to each other, right? We have carbon. Now they have to have 7 hydrogen, so this will take 3 hydrogen. This takes hydrogen, right? Now for this last carbon 3 is attached to one other carbon, right? Now this carbon obviously has OOH attached to it. So how do we represent that? Carbon here is going to have a double bond with oxygen, right? But since this is not carbon but rather oxygen, this is not an alkene, right? And then here we're going to have a OH functional group. Now O and OH, this is not an alkanol, that is an alkene, but wherever you have the functional group COOH, yes, this is COOH, the functional group, we call this an alkanoic acid. So that is generally, that's the name, right? We call this alkanoic acids. So now let's name. This is not going to be difficult to name actually. We just have the longest carbon chain to be 4 carbons, and of course the prefix for 4 carbon is butan, so that becomes butanoic acids. So it was that easy, right? So butanoic acids. Alright, so and that was all questions for today. So comment whichever question you'd like us to treat next in our next video.